Once again, our objective, I can write and graph a quadratic equation of a parabola. So we're still on parabolas. We don't need a prayer model because sorry, I saw you guys writing in the air. Basically, equidistant points from two things. What are the two things? The focus and directrix. That is correct. So, and the example given last week, I gave you guys the focus, the directrix, and then I explained to you how we come up with a parabola from those two, being that it's equidistant. All the points are equidistant from them too. All right. And then last week I said we're going to come up with an equation which is in standard form known as y equals ax squared or ax squared equals y. This itty-bitty little equation. And I said, but it requires a long process. And here was the process that we came up with last week. We did the sketch. And then we came up with a distance formula for both distances. We simplified, set each distance equal to each other, simplified, and we came up with our standard form equation. Yes? And also, what did we conclude? We said that, oh, Mr. Q, this makes a, no? Heart algebra 2, no? Now, before I get into the second part, look up please. Before it became ax squared equals y, it was 1/4 p x squared equals y, and now we know that a is what? 1/4 p, yes? Okay. However, before we got it in this form, in the y form, it was first x squared equals 4py. This is the way we're going to be working with throughout this chapter or this module. So make sure, and I'll come back to this, x squared equals 4py. We're going to continue to revisit that. However, now that you know by heart this process, copy this. Focus. No, this on your Cornell notes. Directrix. All right, let's see if you follow along. By now, with all the practice that you did over the weekend, right? Hopefully, there's always something there to remind you, yes? Here it goes. What can we conclude? That in order to start a parabola, there should be a point between these two, is that correct? That's the first one we're going to place. There it is. And what do we conclude? That this distance is the same of this distance from that point to a point on the directrix. And for those of us that are a little bit out of place, I said we can draw a straight line down and one across. And there's our coordinate plane. What is this one now? This is y, and this one is our x. Is it crooked or a little bit? There you go. There it is. All right. We good up to right there? All right, let me zoom in. So if that's true, tell your neighbor the coordinates of this point, please. Everyone? 0, 0. That is correct. If that's true, then that means that this one right here be careful, P0. That is correct. If that's true, then this one is what? Tell your neighbor, please. negative P0. That is correct. Pretty clear, yeah? Okay, good. Next, I'm going to place a point somewhere right there. I'm going to label it X, Y. And what do we know? We know that this distance is the same as this distance, so there should be a point here on the directrix. So what shall we label this distance right here? D sub 1, that is correct. Yeah, Cindy, let's go. Wonder what you ate. Maybe some Jack in the Box? Damn. Therefore, what is this one, everyone? D sub 2. And last but not least, find over the coordinates of that last point. Last point. Laisha. Okay, so here's the point of origin, right? For this point, we said negative P0 because the Y value didn't move. It stayed on the same spot. But the X value is negative P. So what is the X value for this one? Negative P, all right. We got that far. Tell you never what goes here. Y. Yes? And now we can sketch half of our parabola. And what do you guys notice now? That it's going to open which direction? To the left. And if it's negative, then it's going to open to the right. All right? And what comes after this? We usually do the distance, da-da-da. Are we going to do that whole thing again? No, because by now, I'm pretty sure you understand this part, yes? So, we ended up with this for the one that we did on Friday, yes? And all these are the same. And those we call a vertical parabola because they open up or they open down. They open up or they open down. Okay. These are the different ones. So now let's think of the one we just did right now. That's known as a horizontal parabola. If I was to have you do the distance formula for D1, D2 equal to each other, simplify, at the end we end up with one equation. Let's focus on this one for right now. What would be the horizontal parabola, the equation in that form? Talk it over to your neighbor. What would be the horizontal parabola equation in that form? What would it look like? What? No talking? Wow. Woo. Okay, how about Danica? What would be our horizontal parabola equation? If this one's for the vertical, then our horizontal should be help her out, Roman, Aguirre. Will the X and the Y switch? Very good. So what would be our equation? Roman for Presidente. Copy that, please. Bam. By the way, what does this remind you of? 3 weeks ago, what did we do? Cindy, Cardenas, She's all, I don't know. What? We did inverse functions. Remember? Inverse, never mind. Oh my goodness. Where we switched the X to the Y. All right, tell your neighbor the other one. What do they look like, please? That is correct. Those are the three different forms. But I want you to I want you to box the first one for each because this is the one we're going to be using throughout. Okay? Put a heart next to it. Aww. Don't forget. Bless you. Okay? All right. Get your graph paper in front of you. So once again, we're focusing on this one for the vertical, this one for the horizontal. Copy this one, example 1. It says, write the equation of the parabola passing through the point of origin with focus 0, 2 and directrix y equals -2. Copy that. You got 40 seconds. Then I'll go over that one with you. Copy and go. That was a classic one. All right, here we go. Let's do this one together. First things first, what is the information that they give us that we for sure know that it's going through what? Point of origin, so place your point on the point of origin. There it is. What else do we know? The focus, I'm going to do that in red since we usually start with a focus in red, is what? 0, 2. 0, 2, which is right there. And in blue, my directrix goes through what? Y equals -2. -2 is right there in blue. There it is. Does that look very familiar to what we did last week with the setup of the sketch? So which way is the parabola going to open? It's opening up, so it's a vertical, yes? So right away, we can identify it's a vertical parabola, which means which equation am I going to use, everyone? X squared equals 4py. Write that in there. You're like, okay. Next, on our original focus, think about this one. Last week, what were the coordinates? 0, p. Is that correct? But here now, what do we have? So what do? Substitute the 2 inside the p. So therefore, we end up with x squared equals 4 times 2 times y. X squared equals 8y. And this is my equation for the parabola. All right, now we just need to graph. What do? Somebody asked you to graph. What would you do with that? A table, that is correct. X, Y. -2, -1, 0, 1, 2. All right, I'm going to do the first value. Here we go. I'm going to use blue. So -2 goes in here to to x squared. So what is squared? What is -2 squared? 4 equals 8y. So to solve for y, what do? Divide by 8. Therefore, y is equal to 1/2. Does everybody see where we got that from? Yeah, 4 over 8 is 1/2. Next, what's my next value? -1. So what is -1 squared? 1 equals 8y. Divide by 8. So what is y? 1, 8. How about 0? 0 because we already have our point of origin. Let's graph those three. -2, 1/2. -2, 1/2. -1, 1/8. Negative 1, 1/8, about right there. 0, 0. And what do you guys notice 0, 0 is? Our vertex, right? Which means what is 1? 1 of x is 1/8 of y, that is correct. And 2 of x is what? 1/2, that is correct. And we graph our parabola. Are we done? Yeah, it says, write an equation. Did we write the equation? Yes, there it is. Did we graph the equation? Write the equation, the parabola passing through. Okay. It didn't say graph, my bad. I forgot to put graph. But did we graph it? Yes. Tell me, listeners, how confused you are with these? 5 fours, 5 fours. Okay. Let's crank it up a notch. Yes. All right. Go to your next coordinate plane. Copy this one. You don't have to copy the instructions. We know it's passing through the point of origin, but the focus is 5, 0, and the directrix x equals -5. Do this one together. So, where's our focus? 5 of x, 0 of y. Where's that at? 5 of x, 0 of y is right there. Where's our directrix? At x equals -5. X equals -5 is right here. That means there's a straight line going through -5 of x. And of course, the point on the origin, we know it's there. Question: which way is the parabola going to open? To the right. You guys see the focus over here? So it's going to open to the right. So what kind of equation are we going to write? For horizontal, is that correct? Therefore, y squared equals 4p of x. All right. So instead of p, what do I write? 5. So we get y squared equals 4 times 5x. Y squared equals 20x. And that's our equation. Are we done? No, let's graph. X, y, question. Which values am I going to substitute in there now? Y values, because we need positive y values, negative values, so that it can curve. So I need -2, -1, 0, 1, 2 of y. So my first y value is -2. So what is -2 squared? 4 equals 20x divided by 20. We end up with 1/5. That is correct. Next value, -1. What is -1 squared? 1 equals 20x divided by 20. So this is 1/20. And this one would be what? 0, 0. Let me graph that just so you can see what it looks like. We got -2 of y, and 1/5 x is about right there. We got -1 of y, and 1/20th, very close to the line right there. That means on the other side is right there. Right there. Oh, sorry. And here's a parabola. All right. So once again, guys, home plate is on page 183, 184, numbers 1 through 4, 7 and 8. Have a good one, guys. Enjoy your home plate. See you guys tomorrow. Bye.